Good evening, sir.
Good evening, sir.
Hello. Yes, I'm audible.
Yes, sir, you are audible.
Yeah, okay. Hi guys, good evening.
Good evening, sir.
Okay, so we will start the class today. Okay. So I think last class we saw the timers, right? Timers for PWM and for the delay. Okay, so both the things we have explained last class. Okay, just a minute. Close project. Okay. So today we are going to see just a minute, I open the attendance. Okay. Yeah. I'll share my screen. So, so today what we are going to see is today we are going to see the communication protocol. The first communication protocol is UART. Okay, so that we will see how to configure the UART. UART also we can able to configure by using a polling method, and also we can able to configure it with DMA and interrupt method. Okay, so we will see all these things, how to configure the UART in the polling method, how to transfer the data, how to visualize the data, and similarly for the interrupt mode as well as a DM mode. Okay, so that we are going to see today. So before that, I think you people already know about this UART in PIC, right? Okay, so I want you people to know about tell about that. Okay, I'll just open the OneNote. Okay, tell me what is UART. So this session, you people are going to tell me what is everything. I'll just simply put serial communication. Okay. So first tell me what is serial communication. So this thing you already studied in the PIC microcontroller. Okay, so that's why I'm asking you. Yes. What is serial communication? Sure. Yes, guys. Am I audible?
Yes, sir.
Okay. So tell me what is serial communication? The communication protocol topic is very important in the microcontroller topic. Okay, so whenever you put that you know about this microcontroller in your resume, the questions will be mostly coming from the communication protocols. Okay, so you have to be thorough in that, and yeah, Just tell me what you know about the serial communication, or what are the different types of serial communication available. Yes, these things you already studied in PIC microcontrollers. That's why I'm asking you. Even if you didn't study it in your college days or in your workplace, that doesn't matter. But you already studied this in PIC microcontroller. That's why I'm asking you, what is serial communication, or what are the different types of serial communication available? Simple.
Device 1 and device 2 connected in this.
Sarana, your voice is too low.
Sir,
Yeah.
sir, device 1 and device 2 connected with series, sir. Transmit and receive also connected in same
Okay.
same to device 1 to device 2.
Okay. That is serial communication. Right. What are the different types of
First
serial
one,
communication? Yes.
yes, first device transmitted connect to another device receiver, sir. Same receiver also connect to another device transmitter.
Okay, that is
Like,
UART. Okay,
Sir,
no issues.
bit by bit, we can communicate through the in between the device.
Okay.
So we have two types of synchronous and asynchronous.
Okay.
On transmission types also, off duplex and full duplex we have.
Okay. So assume you are having so both of you good and thanks. Okay, let's assume you are having two different devices. One is D1, device number 1, and device number 2. Okay. If you want to transmit an 8-bit of data, for example, 1, 2, 3, 4, 5, 6, and 8. Okay. Let's assume you need to transfer a data like 10110010. Okay, so this is what the data you are going to transmit from device 1 to device 2. So assume this device 1 is your sender and your device 2 is your receiver. Okay, so there are two possible ways of transferring this data from device 1 to device 2. That is, you can able to transfer this 8-bit of data at a time. Okay, for that you required 8 different lines. Let's assume you are having 3, 4, 5, 6. Okay, and you're having 7 and 8, something like this. Assume you are having 8 different wires. Each and every wire is carrying the individual bits. Okay, the first one is carrying the bit number 1, and second one is 0. So third one is 1, fourth one is 1, fifth one is 0, 0, 1, 0. Okay, if you could able to transfer all these bits of information from device 1 to device 2, okay, with this much amount of cables or wires, we call this as a parallel communication. Okay, so all these bits or all the datas are transferred parallelly from the sender to receiver. Okay, so that is what called as a parallel communication. It is very fast. That is an advantage. But the disadvantage here is you require more number of wires. For transferring an 8-bit of data, you require 8 wires. For transferring a 32-bit of data, you require 32 different wires. Okay, so there are too much of communication or connections has to be happen from one device to another device. So that is the issue. Okay, now in order to avoid that, what we will do, we are just going to connect only one pin. Okay, it may be 2 or a 3 or a 4, depends on which protocol you are using. But imagine you are having only one signal pin. Okay, in the signal pin, if I transfer this, first I will take this one, I will transfer it from device 1 to device 2. Okay, so now device 2 received 1. Okay, then I am transferring this 0. So that is 0. Then I'm transferring this 1. Okay. So if I transfer a bit by bit of data from this device 1 to device 2 through a single wire, then we call it as a serial communication. Okay. So the data are transferring in a series manner from one device to another device in a single wire. So we call that as a serial communication. Okay. So the advantage of this serial communication is it is fast, but not as fast as your parallel communication. Okay. But you can transfer the data fast with minimal loss. Also, it requires a less number of wires. Okay. So the cost is reduced. The complexity is reduced since it has a less number of wires and all these things. So we prefer to transfer data in a serial communication in our microcontroller rather than the parallel communication. Okay. And we have something called as a bus communication topology. All these things will come later with your CAN, LIN and all these things. Okay. FlexRay, Ethernet, all these things will come. But serial communication, you're going to transfer the data from one device to another device in a single wire bit by bit. That is what a serial communication is. Okay. Always remember this. When you go for an interview and interviewer asks what is serial communication, if you are not able to answer it, then there is nothing, right? Okay. So keep this in mind. Okay. Now this serial communication, that is transferring from one device to another device, it can be done by using a different methods. We call that as a protocol. Just a minute. Yeah, we call that as a protocol. Okay. So there are multiple protocols. Protocols is nothing but how you are going to transfer the data from one device to another device. That is what called as a protocol. Okay. So here we'll be having a different kinds of protocols that we can able to use for transferring the data. So our ultimate aim is transferring the data from one place to another place. That is what your microcontroller is also doing. Okay, transferring or taking the data from your memory to the RAM, from RAM to CPU. CPU it will process and send it the data back to the RAM, from RAM to the register again. Okay, it is again a data transfer. So your microcontroller itself is doing this data transfer. You are going to calculate the data, you are going to process the data, and you are going to either control any devices or you are going to transmit. Okay. So at the end of the day, what you're going to do is you're going to transmit the data from one device to another device or one peripheral to another peripheral. Okay, that is what an ultimate aim of any microcontroller application. Okay, so that's why I already said communication protocol is very important, right? So depends on this how you are going to transmit the data from one device to another device bit by bit. Your serial communication is going to be classified as first one. You'll be having an USART. Okay. In this USART, you'll be going to use something called as an UART that we will see. Then you are going to have something called as an SPI. Then I2C or I2C. We can call it as an I2C or I2C or IEC, whatever it is. Okay. And we'll be having something called as a CAN. Okay. Then we'll be having much more devices like LIN, FlexRay, Ethernet. Okay, so on. There are multiple communication protocols available. Okay, so in our module, we are just going to see these 4 protocols, and I will just give a glimpse of what this LIN, FlexRay, and Ethernet is. Since if you want to go for any automotive company, you should know these 3 things. Okay, and a bit of Ethernet also. So I'll just explain this LIN, FlexRay, and Ethernet a bit, but we will see a program for these 4 things. Okay, so first one, today we are going to see the USART or UART. Okay, so that we are going to see. So this is what the protocols of serial communications. So we call these as a protocols. Okay, so protocols are nothing but how you are going to transfer the data. Okay, that is what a protocol is. It's a set of what we call a set of rules, something like that. Okay, that is what the protocols is. Okay, so today we are going to see this USAT. So I'll take this USAT. So USAT, yeah, what is USAT?
Universal, synchronous and asynchronous receiver and transmitter.
Okay, nice. Okay, so this is what the expansion of the USAT, universal synchronous asynchronous receiver and transmitter. Okay, that name itself tells it is an universal protocol for both the receiver as well as a transceiver or transmitter. We can able to send the data in a synchronous mode or an asynchronous mode. Okay, now there comes one more thing. What is synchronous and what is asynchronous? Okay, so that we need to know. Okay, so I'll just write it over here. I'll just put a sync and I'll just put an async over here. Okay, what is synchronous protocol? I thought you people already know about all these things, so I can skip the theory part and teach only the program. But okay, no issues. If you already know this, just let me know. I'll skip this and I'll directly go to the program. Okay, so that we don't want to waste the time. Or if you want me to teach it, just tell that also I will teach it. That's your call only. Since you people already studied this in PIC microcontroller, I'm just asking you this one. If you want me to teach the basics of all this, I'll teach it. Or if you already know this, if you want to skip the theory part, then we can directly go to the program. Your call. If you can't speak, you can put in a chat box. Or those who want me to teach, there is a raise, right? This raise your hand. You can just write this so that I will know how many people want me to teach it again. Or just unmute and speak. Okay. Okay. Anyone else? So others, you people already know about this one. We take it like that. Mohammed, Arvind. Okay. Guru. Venkatesh.
Yes, sir.
You already know. Just each by experience. Okay. Okay, now just I'll teach that one. Okay, no issues. Yeah, so what is synchronous? Okay, so for transferring this data from one device to another device, that is from a sender to receiver, if we require a clock pulse, okay, or I'll say like this, we can transfer the data from the sender to receiver through this clock pulse only. Okay, then we call that as a synchronous communication. Okay, we require a clock pulse for transferring the data from the sender to receiver. This is what a clock pulse is. Okay, so last class we saw what is a clock pulse, right? In our case, it can be an 8 megahertz to some boards has 72 megahertz, some board has something like an 170 megahertz. So that is your clock pulse. Okay, so by using this clock pulse, if you want to transfer a data from one device to another device, then we call that as a synchronous. But there is another thing. For the synchronous communication, since you are going to transferring the data from or via this clock pulse, the clock pulse of the sender as well as the receiver has to match. Okay. Why? Because you are going to transfer the data. For example, let's assume you are going to transfer the data on each I pulses. Okay. Whenever you are having an I pulse, you are going to transfer the data. Okay. From the sender. So sender is going to transfer the data whenever there is an I pulse. Okay. And your sender is having something like an 8 megahertz of clock frequency. Okay. Okay, 8 megahertz of clock frequency. Let's assume this is your sender. Okay. And your receiver is having something like a 20 megahertz of clock frequency. Okay. So that means it is actually something like a twice the number, right? So every one pulses, it will have a 2 pulse. Something like this. Okay. So in receiver side, what will happen? It will actually check the response of each and every I pulses. It can be a low pulse also, but let's assume you are configuring as every I pulse I'm going to receive and every I pulse I'm going to transfer the data. That's what I'm configured. Okay, imagine like that. Now, what will happen for every I pulses? It will expect the sender to transfer some data. But what happens for every 2 pulses only? It is going to transfer one data. Okay, so there will be some loss of data will be there. Okay, this particular data will not be properly received from this sender to receiver. Okay, so in order to transfer a data from the sender to receiver, both this clock pulse has to be matched. Okay, it can be an rising edge or it can be a falling edge, wherever you can transfer the data, wherever you can receive the data, but the clock pulse of both the sender and receiver has to be matched in the synchronous communication. Okay, if it doesn't, then you can't be able to transfer the data. Okay, then what is the speed of transferring this signal? The speed of transferring this data is depends upon your clock pulse. Okay, whatever your clock pulse speed is, that much speed this data can be transferred. Okay, that is a simple thing. This synchronous communication. Okay, now in some cases we couldn't able to match the frequency of both the devices. For example, if you are having an ADC, that ADC can run in a different clock pulse, and if you are having a timer, that timer will be running in a different clock pulse. Okay, so if your timer wants to send some data to the ADC or ADC wants to send some data to some other devices, the clock pulse will not be matched because both are working independently. Okay, so it need not to be always the clock pulse has to be matched with the sender and receiver. Okay, in that case, what we will do, we will go for something called as an asynchronous communication. Okay, it doesn't require a clock pulse. So clock pulse is not needed for transferring the data. Okay, if the clock pulse is not needed, then how can I able to transfer the data? Or here I know the speed of transferring the data will be based on the clock pulse, right? So if it is 8 megahertz, then if I put something like a t is equal to 1 by f, I'll get a time period for transferring a 1 bit of data. Okay, that I can easily able to calculate. But if I don't have a clock pulse, then what is the speed? Or how my receiver know where is my data starts and where is my data ends? Okay, and one more thing, when can I receive the data and when can I stop receiving the data? Or do I need to always be in open for receiving the data? There are multiple problems occur if you doesn't have any clock pulse. Okay, so for that, there is something called as baud rate comes into picture. Okay, so what is meant by baud rate is something like a data transferring rate. Okay, so how much speed the data is going to be transferred, that is what called as an baud rate. So this baud rate can be varied something like an 1200, 2400, 4800, 9600. Okay, we have 119200. Okay, it will just go on. Depends on which application you are going to use. Okay, you can be able to set the clock pulse, and the most commonly used clock pulses are like 9600, and we'll be having something like an 115200. Okay, that is another clock, sorry, baud rate. Okay, these two are most commonly used clock pulses. Okay, it can be very depends on your application, but these are most commonly used. Okay, so this is how we can tell both the sender and receiver transfer the data at this speed, and you're telling the receiver receiving the data at this speed. Okay, so that is how we'll be transferring and receiving the data. Okay, so this is what an asynchronous communication. Okay, one problem is solved. I know how much the data is going to be transferred, right? So that is problem solved. So second problem is, when can I receive the data? When can I stop expecting the data to be received? Okay, for that we'll be having something called as a frame format. Okay, for the asynchronous communication, we'll be having a frame format. That is, the data will start here, the data will end here. Okay, and how many data bit will be there, and when you are going to start receiving the data, when you are going to stop receiving this data, all these informations will be available in this frame format. Okay, so this frame format is available for for the UART. A frame format is available for I think we don't have for SPI. Okay, we have for an I2C, and we have for a CAN protocol. Okay, and for Lin we don't have, I think. Yeah, so this we will be having a frame format for all these things. We will see one by one what are the things. Okay, so first thing, we'll be having a baud rate for fixing the data transferring rate, and the second thing is you're just going to give a frame format that this is how the data will be transferred. Okay, so that will happen in this asynchronous communication. It is quite what we will say a complex, not exactly a complex, but we need to configure more things here as compared to the synchronous communication, but it is more reliable since it doesn't require the clock pulse for communication. Okay, and we'll be having some code checking and all, bit by bit check. CRC will be having a parity check, all these things. We will see one by one what it is under. Okay, so this is what a difference between synchronous communication and asynchronous communication. Okay, clear? Any doubts in this?
Clear, sir.
Yes, sir.
Now, based on this USART can be both synchronous as well as it can be asynchronous. Okay, so that is what this USART is. So in USART, we call this as a two-wire communication, or it is a very simple communication as compared to any other communication protocol. Okay, I'll just say very simple protocol for transferring the data. Okay, we have two different pins. Okay, or two different devices. Let's assume we will be having two different devices. We call this as an peer-to-peer communication. Okay, that is from one device to another device. At a time, we can able to connect one to one only. So let's assume this is my same thing, device number 1, and this is my device number 2. Okay, so in device number 1, we will be having two pins, that is TX and RX. And here also we'll be having a TX and RX. Okay, so for this USART communication, will be requiring only two pins, And apart from this, we'll be having a ground pin that is obviously normal for all this communication. So if you want to connect from one device to another device, this transmission will send the data to this receiver. Okay. And similarly, this transmitter is going to send the data to this receiver. That's it. Very simple communication. Okay, it is one-on-one communication. Only one device will transfer a data to another device. That's it. The TX of this will connect to RX of this one, and TX of this one will connect to RX of this one. Okay. Now, if you want a clock pulse, that is a synchronous communication, then you need to connect a clock source for these two things to be connected for transferring this data. Okay, but if you don't have, then you can just leave it for some UART. Okay. Now we are going to see only this asynchronous communication. We are not going to go deep on the synchronous communication. We'll only see this UART. Okay. So if you're going to use only the asynchronous communication, instead of USART, you'll be calling it as an UART, that is Universal Asynchronous Receiver and Transmitter.
Sir,
So this is, yeah.
so any advantage is there for using clock pulse?
The advantage of using, yeah, it is very simple. That is, we no need to configure like all these things like a frame format, baud rate, and all these things. Only the clock pulse has to be matched. That's
Okay.
it. Okay. This we will see in this I2C and SPA. Both are synchronous communication only. Okay, we will see there how this data will be transferred in the clock pulse. Okay. So UART is an universal asynchronous receiver transmitter that we already know. This is what the diagram for UART. Okay, the same thing. Now, there is something called as a frame format, or the baud rate is as like already told you. We just need to configure the baud rate and all these things. Okay. So apart from this, we'll be having an frame format. Okay, so frame format. Okay, how we are going to transfer the data from the sender to receiver. Okay, so that is what a frame format is. We are going to see that right now. Okay, so your UART is having, let's assume you are going to, okay, yeah, your UART are mostly an 8-bit of communication only. Okay, so let's assume this is my frame format. Okay, so okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So the frame format for UART is, it will start with the start bit. Okay. So there is a first bit which is called as an start bit. Okay. After start bit, we'll be having the data. That is, let's assume we'll be having a data from D0, D1, D2, D3, D4, D5, D6, and D7. Okay, after D7, we'll be having something called as an stop bit. Okay. So this is what an start bit, stop bit, and we call this as the data frame. We are going to transfer an 8-bit of data in the UART. Okay. After this, the next start bit will come and all these things will happen. Okay. Now, how we are going to define the start bit and stop bit is, all these things are pulses only. Right? For example, if you're going to transfer, let's say you're going to transfer the value called as C. Okay, capital C. So this capital C will be converted into a binary value. For example, your capital C is having something like an 65, 60, 67 as an ASCII value. Okay. No, small c is 67, capital C is 97, 98. It's 99 for capital C. No, I think, sorry, I'm having a bit confusion whether it is in capital or a small. So you know about this ASCII table, right? All the values
Yes.
which are present in your keyboard, it has a specific hexadecimal and decimal value. Yeah, so capital C is 67 only. I was correct. Okay. So your capital C is having 67. If you didn't notice, you can see over here, this 67 is for the capital C. Okay. Similarly, small c is having 99. And we'll be having the values for all these keys in your keyboards. Okay. Numbers, your percentage, hash, even for a space and all these things. Okay. So now this is 67 and or I'll just take an hexadecimal value. That will be very simple. So hexadecimal value for C is 43. Okay, so this is what an hexadecimal value 43. Okay, so if I just convert this into binary, what is the binary value of 43? From hexadecimal to binary. How will you convert an hexadecimal to binary?
So 0100
0100. Okay.
and 0011.
1, 1.
Okay. So
Actually,
this
4
4 will
separate
be,
and 3
yeah,
is this side.
4 is separate and 3 is separate. So 4 is 0100. And for 3, you'll be having 0011. Okay, this is what an 8-bit value. So this D0 to D7, this will be your D0 to D7. Okay, so that is what your data. Each and every data will be having an, the pulses. Okay, so ones and zero pulses kind of things. Okay, now I know the data frame. That is the 0 and 1. For 0, you'll be having a low pulse. For 1, you will be having an high pulse. Okay, now what is, so how to denote the start pulse and how to denote the stop pulse? Okay, so that is what the thing is. So for start pulse, you will be having from high pulse to the low pulse. Okay, so this is what your start pulse is. That is, or if you say in the technical term, the falling edge will be always called as a start bit. Okay, and this falling edge will match with something like your clock pulse over here. If the clock pulse is high, at the same time, if your start bit is as a falling edge, then we call it as a start bit. Okay, so from high to low, we call this as a start bit. Okay, after this, from D0 to D7, we'll be having. I know what is D0 to D7 value. So my D0 value will be 0, and I'll be having a 1 on the D1, and I'll be having a 0, 0, again 2 more 0, 0, 0, and I'll be having a 1 and another 1. Okay, like how this start bit is from high to low. Similarly, my stop bit will be from low to high. Okay. Is it clear? I'll just write the values over here. So this will be my 1, 0, 0, 0, 0, 1, 1. And this is my 0. Okay. Now, the width of each and every pulses here actually defines based on your baud rate. Okay. If your baud rate is 9600, the formula for calculating the bit width is width equal to 1 divided by baud rate. Okay, so that is what things. If it is 9600, your width, pulse width will be somewhere around 104 point something, like 1.6 something will come microsecond. Okay, so this is for the 9600. Okay, and similarly for 115200, can anyone calculate and tell me? Just put 115200, 1 by 115200, and tell me what is the width. 1 divided by 115200.
$8.680.
8.68 microseconds, right? Hello. Guys, I'm audible.
Yes, sir.
Yes, sir. Yes, sir.
Did you hear what I said? Yes, no.
Yes, sir. Screen
Hmm.
is not visible.
No, no. That's what I said. Uh, Here power cut actually. So my PC turned off. I'll just let you know in the group when the power resumes.
Okay.
Yeah.
Okay, sir.
Yes. Yes. You can leave if you want. Okay, I'll just put in the group when the power resumes. Or if you have anything to ask, any doubts, you can just ask me right now. I'll explain. Or you can leave. I'll just uh, tell you in the group. Okay.
Okay.
Yes, sir.
Sir,
Yes, Mohammed.
yeah, sir, approximately how many like take days it will take to complete this course?
The entire course or this module?
No, entire course.
Entire course, it will be 6 month max. 6 months of working days. I'm saying.
Okay, okay.
Okay, that is 180 days, 180 working days.
So still like uh, RTOS also pending. Then after that, what will be there?
Then we'll be having an IoT.
Okay.
Okay, using this Raspberry Pi and AWS IoT
Mhm.
core. Then we'll be having a Linux system programming.
Mhm.
Okay, and then we will
Okay.
have a glimpse of this automotive softwares like MBD, RTOS, and all these things.
Okay.
So that we will see. Okay, I think we will be having 1, 2, 3, 4 modules max.
How about verification and validation?
And that also will come in the software defined vehicles. It's a theory part only. Okay, so that will be covered in the software defined vehicle part.
The testing won't be there, sir. Like unit testing,
Uh,
integration testing.
yeah, that will be covered in the theory part only. Tell you what this testing and all these things, since we don't have any tool for doing this testing. Okay,
Okay.
if possible, we can do that with the MATLAB, but you can't be able to do the unit testing, integration testing, component testing, all these things individually in the MATLAB. You can just do only one testing, and we can generate the report in the HTML format. That is possible.
Mhm.
Mm, but theory part we'll see for all these things.
Okay. And project like
Project will be for each and every modules will be there, and I'm yet to give for the C++ and the PIC project. Um, okay,
okay, sir, thanks.
I'll share tomorrow morning this C++ and PIC question. Okay,
Okay.
the project titles. Choose
Mhm.
one from the the list of projects as like how you did for C program. Um, if you have any doubts or any explanation needed for that particular question or project you have selected, just let me know. I will teach in tomorrow's class. Okay.
Okay, sir.
Tomorrow morning, I will share the project title.
Okay.
Yeah. For C++ and PIC both. So for PIC microcontroller, you have to submit both the Proteus simulation file as well as this mplab main.c. Okay. Both you have to upload in the GitHub. Yeah.
So we use the AI models for this embedded system.
Which module?
entire embedded system, what type of AI, like
We'll
AI?
we'll be using AI, Edge AI. Okay. As of now, we'll be teaching this by using a Raspberry Pi for training and testing the model. We are planning to procure NVIDIA Jetson board. It's still not available for sale in India. So we are trying to contact them. Mostly, it will be our last module only. So that is maybe it will be around some 2 months. Before that, we will try to procure that NVIDIA Jetson Nano. Okay, if we got that, then we will see the demo by using this NVIDIA Jetson Nano. Okay, how to train an AI module by using that.
Yes, sir. Okay.
Yeah.
Sir, writing requirements, sir, you know that one?
Mm, requirements for the projects.
Yes, like in software life cycle, development
Mm,
life cycle, we have like
yeah,
writing
development
requirement,
will be
designing.
requirement only.
Yeah.
Yeah,
So,
I have a sample requirement
mhm,
since I teach this MBD. That MBD
mhm,
first part will be the requirement only. So I have a sample requirement for multiple automotive modules like this wiper control, adaptive cruise control, emergency, automatic emergency braking for all these things. But
mhm,
I don't know, is that what the exact requirement that is given in the company? Okay.
okay.
So I have taken this MBD for a Vistian students. So I confirmed with them. They said it is somewhere 70 to 80 percentage of similarities between this requirement to them. Since they are working in the testing, they don't know how this development requirement will be. And they said it will be something similar to this. So I have a requirement document, but it's not an 100% accurate to these companies. And we couldn't be able to get the company requirement data also, right? That is very difficult. And if any one of you have got any development requirement from the company, I know it is not illegal to share that, but uh, just give some input like how it will be so that we can able to create an the exact replica of that requirement model for the development. Okay.
Mhm.
Yeah. A company will not easily share that requirement document with others.
Sir, I'm working in Boeing for Boeing project. So
Okay.
we have system requirements. Like
System
how,
hmm,
yeah, for
for
systems are
development,
there. So
for
yeah.
testing.
After that, after system requirement, this comes in picture like high level requirement, low level requirement.
Mm-hmm. Okay. Okay.
It's
So is it
different.
for development or testing?
No, still before development, before development, this system requirements are they are working on that. After
Yeah, that.
once this complete,
Yes.
then they
Yeah.
will come to.
No, so what will happen for the testing team? They will be having a different, since automotive companies are working in a V cycle model. There will be a different requirement for the testing team.
Okay.
That's what I'm asking, whether it is for the development. So you do development of the project with that requirement, right?
I'm not sure actually. I'm not clear with that. Like what they will do with this requirement after that.
Mm. Okay, okay, okay. We will see that one.
If you want to learn how to write requirement, is it possible?
Um, no, only the company
Because there
people.
is one. certification is there, no? IREB, something like that.
Which one? IR?
EB, something like that is there.
Just a minute.
IREB.
IREB certification. Okay, so that is for requirements engineering training. Okay.
Mhm.
Certified professional for. Okay, nice. Okay, I'll just check this one.
Mhm.
So this IRAB is common for all the domains of industries, or is it any
Uh,
specific domain?
I think it is common, or maybe in automotive they're using, but I think it is common. Previous
Okay,
company, actually, one of my manager told that like you have
it's
to prepare
certified.
for this. Yeah. But
Mhm.
I don't know, nothing happened. That's it. I don't have any idea. I just want to learn how to write requirements.
Okay.
Yeah, but I didn't find. Then I joined this course.
Okay, okay. Mm, so you have to write an exams. So register.
It is
Okay.
same like ISTQB, like how ISTQB is there, no? For requirement, this is certification.
Okay.
Sir, we are going to use RTOS, right, on this module or upcoming module?
Upcoming model with the same board.
Okay,
Since
sir.
here we are writing for the device driver, right? So how to write the same
Ah,
things, the RTOS that we will see after this one.
okay. So I think it's also okay. This we are doing bare metal with this device driver. So in future we are going to use in the OS with
Mm,
RTOS.
yeah.
Okay.
Here we'll be mostly using this AL APIs, right? So AL APIs are polling methods unless you are configured it with an interrupt. Okay.
Okay. Sir.
So
Okay.
RTOS, we can do the parallel processing with the same thing.
So naturally it has some APIs. We going to use RTOS APIs.
Yes.
Is that or
Yeah.
like the OS we going to infuse in the board itself?
Yeah. So we are going to convert this normal STM board into an RTOS specified board, real-time embedded board. There will be
Okay.
some APIs will be there. So there are multiple OS providers for this RTOS. So one such thing is a free RTOS. It is an open source RTOS program for this real-time operating system. So we'll be using this free RTOS for configuring this STM one. We are going to use their APIs.
Okay.
Yeah.
That's strong.
இது ஒன்று பெண்டா இருக்கா லாஸ்ட் எண்ட் வரைக்கும் போயிட்டு போல எண்ட் வரைக்கும் போல
Like is not
இது
on.
எண்ட் வரைக்கும் போயிடுச்சு
Okay, guys, you can leave. I will just let you know if the power resumes. Okay. If it is comes within some, what is the time now? Okay, if it comes before this 8:45 something, we will take extend the class up to 9:30. Okay, before that, if it comes, I will let you know. Or else we will take 1 hour extra tomorrow. Okay, if the power doesn't comes till 8:45. I'm saying. Okay.
Okay, sir.
Yeah, you
Thank
can leave now.
you.
I'll just let you know in the group.
Okay.
Yeah. Okay. Thank you.
Thank you, sir.
Yes, sir. Thank you.
அந்த குரூப்ல அப்டேட் பண்ணுங்க சார்.
ஓகே சொல்றேன். நான் உங்களுக்கு இண்டிவிஜுவலா மெசேஜ் பண்றேன்.
ஓகே.
ஓகே.
Yes, sir. Thank you.
Thank you.
Thank you, sir.
Thank you, Guru.
Sir, are you working same departments as embedded system?
Yeah.
Right now you are teaching or working
Teaching.
only?
Yes.
Yeah. Okay, sir.
Yeah. Okay.
Okay, sir. I will know experience what it is. I will take another time. Okay.
Yeah. Okay. Precious.
Thank you, sir.
Yeah. Thank you.
சார்
Yes, Navin.
சார் எஸ்டிஎம் போர்டு ஒன்று அந்த ஒரு மாடல் மட்டும் நான் சொல்கிறேன். அந்த போர்டு வாங்கலாமா ஜஸ்ட் மட்டும் அது மட்டும் சொல்ல முடியுமா சார்?
ஓகே. என்ன மாடல்?
ஜஸ்ட் இது சார் STM32F072RB.
ஒரே நிமிஷம். கொஞ்சம் ஜூம் பண்றீங்களா?
சார்
இல்ல போர்டு இல்ல, மேல இமேஜ் தான் இருக்கா?
எஸ் சார், ஸ்க்ரீன்ஷாட் மட்டும் எடுத்து வச்சு.
ஓகே, ஒரே நிமிஷம் நான் செக் பண்ணிக்கிறேன் என்ன மாடல்ன்ட்டு.
ஓகேங்க சார்.
F072RBயா?
எஸ் சார்.
Nucleo board.
ரோபோ.inல செக் பண்ணதுல எதுவுமே ஸ்டாக் இல்லைங்க சார். எல்லாமே ஸ்டாக் இல்லாத மாதிரி காமிக்குது. ஒன்று தான் ஸ்டாக் இருந்துச்சு.
ஓகே. ரோபோலியா?
எஸ் சார்.
அது ஆக்சுவலி நீங்க செக் பண்ணிட்டே இருக்கணும். காலையில ஸ்டாக் இல்லைன்னு வரும், திடீர்னு மதியம் ஒரு 4 போர்டு மட்டும் அவைலபிளா இருக்கும். அந்த மாதிரி தான் ஆட் பண்ணுவாங்க. அவங்களுக்கு எப்போ வருது அப்படின்ற மாதிரி.
ஓகே. நான் நேற்று செக் பண்ணேன், என்னைக்கும் செக் பண்ணேன். எல்லாமே அவுட் ஆஃப் ஸ்டாக்லேயே இருக்கு. ஸோ அதான் இந்த போர்டு இப்போ அவைலபிளாக இருந்துச்சு. ஸோ அதான் உங்கள்கிட்ட கேட்குறது, வாங்கி ட்ரை பண்ணி பார்க்கலாமா?
நான் இது என்ன சீரீஸ்னு மட்டும் செக் பண்ணிக்கிறேன்.
ஓகேங்க சார்.
Data sheet.
சார்
இல்ல, இது வந்து M0 ஆர்கிடெக்சரு.
ஓகே.
பழைய போர்டு M0 பேசிக் போர்டு நான் சொன்னேன் இல்லையா, M0 இருக்குன்ட்டு.
ஓகே.
நீங்க வந்து ஒண்ணும் இல்லை, நீங்க எந்த போர்டு பாக்குறீங்களோ அந்த போர்டு M4 ஆர்கிடெக்சரான்னு மட்டும் செக் பண்ணிக்கங்க. என்ன சீரீஸா வேணா இருக்கட்டும்.
ஓகேங்க சார்.
M4 சீரீஸா மட்டும் செக் பண்ணிக்கங்க, அவ்வளவுதான்.
ஓகே சார். இதுல இது சார் செக் பண்றது இதுல M4 M0.
டேட்டா ஷீட் டவுன்லோட் பண்ணீங்க அப்படின்னா டேட்டா ஷீட்லயே போட்டிருக்கோம் என்ன
ஓகே
போர்டு
ஓகே
அப்படின்னு. ஓகேங்களா,
ஓகே ஓகே
அது நீங்க
ஓகேங்க
பார்த்தாலே தெரியும் M4 ஆர்கிடெக்சரா இல்லையான்னு.
ஓகே ஓகேங்க சார்.
இல்லைன்னா நீங்க எஸ்டிஎம் வெப்சைட்டுக்கு போனீங்கன்னா அவங்களே கொடுத்துருப்பாங்க, மேல டைட்டில்லே வரும் என்ன சீரிஸ் அப்படின்னு சொல்லிட்டு.
ஓகே ஓகே ஓகேங்க சார், நான் செக் பண்றேன் சார்.
ம் ஓகே,
ஓகேங்க சார். ஓகேங்க சார்,
ஏதோ ஒரு
தேங்க்யூ சார்.
M4 சீரிஸ் எது அவைலபிளா இருக்கோ அது வாங்கிக்கோங்க. ஏன்னா நம்ம
ஓ-
RTOS யூஸ் பண்ணும்போது M4 சீரிஸ் இருந்தா பெட்டரா இருக்கும், அதுக்காக தான்.
ஓகே ஓகே ஓகேங்க சார். M4 சீரிஸ். ஓகே
M4 சீரிஸ்.
ஓகே ஓகேங்க சார். நான் இல்லைனா வேற ஏதாச்சும் M4 சீரிஸ்ல வேற ஏதாவது இருக்கா, ஒரு 4 மாடல் ஏதாவது செக் பண்ணி சொல்றேன் சார் உங்கள்கிட்ட. நீங்க அதை எது செலக்ட் பண்ணி சொன்னீங்கன்னா நான் அதை செக் பண்ணிட்டே இருக்கேன். இன்கேஸ் ஸ்டாக்ல இருந்துச்சுன்னா ஆர்டர் பிளேஸ் பண்ணுங்க.
ஓகேம்மா.
ஓகேங்க சார், தேங்க்யூ.
ஓகே, தேங்க்யூ.